Today we are talking about finding the factors or roots of a polynomial. Depends on the question. So first off, let's talk about a little bit of vocab. We have covered this on 2 previous notes, but that's about it. Outside of that, haven't mentioned it much. Reminder, if you're planning to go to pre-cal next year, you have to have these terms on your radar. Zeros are there are 3 other ways to name these. The solutions, roots, or x-intercepts of an equation. Devices closed, please. You have to be aware that these terms are all interchangeable with one another. Zeros, roots, zero solutions, roots, x-intercepts all refer to the same thing. They're asking for the same thing. This question here is just a little bit of a warm-up for what we're going to be doing later. What are the zeros of y equals x squared plus 8x plus 12? First off, when you see that language there, what are the zeros? This is how I have always interpreted it to help me remember what to do. Set equation equal to 0 and solve. So whenever I've seen what are the zeros, find the zeros, that just means set A equal to 0, and then you'll solve from there. So let's do that. Our equation is x squared plus 8x plus 12 is equal to 0. X squared plus 8x plus 12. There is a word for this kind of problem. What do we call that? Anybody remember? It starts with a T. No one remembers it? Trinomial. That's correct. This is called a trinomial where you have this set up of 3 terms. It's of the form ax squared plus bx plus c. We'll be using a, b, and c in a moment, so that's where those come from. And what we're going to do is factor this trinomial to solve it. So we'll have our 2 sets of factors. X is in the front. And we need to figure out the 2 numbers that go in those parentheses with the x's. So we'll make an ACB chart. Reminder, this is AC, this is A times C. We're multiplying those 2 together. In our problem, A is just 1, and that's the best kind of problem to have. It's the easier type. So we have 1 times 12, which is 12, and B in the middle is 8. Since the 12 is positive, we are going to be adding on the right side to get that number 8 there. Helps narrow down our options. So we want 2 numbers that will add to be the 8. 12 has 3 pairs of factors, 1 and itself, 2 and 6, 3 and 4. And we want to find the 2 numbers that will add to give us 8. I hope you can clearly see that is going to be 2 and 6. 2 plus 6 does give us 8. Those are the 2 numbers that we want. So we have x plus 2, x plus 6. That's the factoring portion. To solve from there, we can now set both of these equal to 0 in their own equations. So we're going to split them up. X plus 2 equals 0. X plus 6 equals 0. We'll solve both of these. I'm going to solve the left one first. Plus 2, so minus 2 on both sides. X is negative 2. Again, plus 6, so minus 6 on both sides. X is negative 6. And those are our answers. We're done. You can create a list if you want so that they're together, but keeping them separate and just boxing both of them, that works too. Questions on this type of problem before we move on? You'll see this again later. All right. Now back to the current unit, synthetic division. Show that x plus 4 is a factor of x cubed minus 7x squared minus 26x plus 72. Then find the remaining factors of the polynomial. First off, this set of instructions here. Show that x plus 4 is a factor. That wording there is key. So these instructions tell you, use synthetic division. And get let's rewind to last week on Friday when we did the synthetic division notes and we talked about interpreting a remainder. If it is a factor, the remainder is equal to what number? What is it? 0. If it's equal to 0, then it is a factor. We don't want a remainder. No remainder is nice. If we do have a remainder, that's not nice. It complicates the answer. So if it is a factor, the remainder is 0. If the remainder is not 0, it's not a factor. Now they're telling us that it is a factor because they're saying show that it is a factor. So you go into this knowing that that is true. So when you do these problems, you have to get remainder 0 on these problems. If you don't get a remainder of 0, that's because a mistake has been made. Go back and look over your work. All right, I'm going to set up just the division first, just the polynomial divided by the factor, and then I'll actually set up the synthetic division. And before I write this out, reminder of that little sneaky thing, check that every single place value is represented. X cubed, x squared, x, no x, we're good. X cubed minus 7x squared minus 26x plus 72 divided by our factor x plus 4. Here's our division problem. Very first thing we do is we flip the sign on the factor. So the plus 4 is going to change to a negative 4. Setting up the synthetic division, we have negative 4 in the backwards L. And then we'll bring down all of these coefficients. Put a 1 on the first one. We have 1, negative 7, negative 26, positive 72. And then don't forget the black line to help us divide up our work. Very first step, we take that first coefficient, 1, and we bring it down. From here, the pattern is multiply, add, until we're out of numbers. So we multiply by that divisor, negative 4. 1 times negative 4 is negative 4. And then we add down. Negative 7 plus negative 4 is negative 11. And we repeat. Negative 11 times negative 4 is positive 44. Watch those signs. And then we add down. Negative 26 plus 44 is positive 18. And again, 18 times negative 4 is negative 72. And we add down for the last time. 72 plus negative 72 is 0, which is what we're looking for on this problem. We need a remainder of 0. Questions on any of the calculations before I move on? Okay. Next, we'll assign place value to build the DP, the depressed polynomial. 0 is the R, the remainder. 18 gets no x, it's our constant. Negative 11 gets an x to the first, and 1 gets an x squared. Let's put that all together to get our DP, our answer. We have 1x squared, I'll just put x squared, minus 11x. 18 is positive, so it gets a plus 18. No x on that. Remainder is 0, so there's no remainder in the answer. We're not done. We're over halfway done with the problem, but there is another part to this. Next part. Then find the remaining factors of the polynomial. I want you to especially pay attention to the words remaining factors. Once we get through all of these notes, you'll see that there are two main problem types here. One of them is dealing with factors, and the other type deals with zeros. The two problems ask for different things, so you have to pay attention to the vocabulary, and you have to understand what they were asking you to do. Because if you go too far or not far enough on either of the problem types, that can cost you points. When it says find the remaining factors, the word factors tells you right there you're going to factor, that's it. Factor the DP. That's all you do from here. Once you do that, you're done. So I'm going to take my DP and bring it up here. X squared minus 11x plus 18. And then we're just going to factor that. Same way we did before with an ACB chart. Our A here is 1, which is helpful to point out. ACB. A times C, 1 times 18, that's just 18. B is negative 11. 18 is positive, so we're adding to get that negative 11. When we have a mixture of signs happening, this information is very helpful. 18 has 3 pairs of factors. 1 and 18, 2 and 9, 3 and 6. Now we want two numbers that will add to negative 11. Let's focus on the 11 first. 2 and 9 do equal 11. How do I get that to equal negative 11? So it is possible. What has to be done? What is it? Make them negative. Yes, we're going to make both of them negative. So we have negative 2 and negative 9. That does give us negative 11. And when we multiply, that's still a positive 18. Negative 2 times negative 9 is positive 18. So these are going to be our factors. So we have our x's. Then we have minus 2 and minus 9. It's just said factor the DP, that's it. So I'm done. I factored the DP. This is my answer. Again, just to reiterate, these are factors. Based on the way they're written, those are factors. That's in the factor form. Zeros look different. We'll get to zeros later. Questions on the process? We're going to do another one of those, but it's slightly more difficult on the factoring side. And the wording's a tad different, but this problem is exactly the same as the previous problem. Given a polynomial and one of its factors, so they're telling you again, this is a factor, x minus 2 is a factor. Find the remaining factors of the polynomial. Same type of problem, just worded a tad differently. First thing I'm going to do is rewrite the problem as division. Check all the place values first. X cubed, x squared, x, no x, we're good. This problem is 2x cubed plus 9x squared minus 11x minus 30 divided by x minus 2. We can start the synthetic division process. The very first thing we do is we take the number inside the parentheses and we change it to a positive 2. It's a negative 2, change the sign, it's now positive. Setting up our synthetic division, we have 2 inside the backwards L. And then we take all of the coefficients, 2, 9, negative 11, negative 30. Draw the line for your workspace. Let's begin. First thing we do is bring down that first coefficient, 2. From here we multiply, add until we're done. 2 times the divisor, 2. 2 times 2 is 4. Add down, 9 plus 4 is 13. And we repeat. 13 times 2 is positive 26. And then we add negative 11 plus 26 is positive 15. Repeat. 15 times 2 is 30. And then we add down. Negative 30 plus 30 is 0, which is what we're wanting for that remainder. Place value, 0 at the end is the remainder. 15 is the constant, so it gets no x. 13 gets an x, and 2 gets an x squared. Let's set up the DP. Starting with the very first number, 2x squared. 13 is positive, so plus 13x. 15 is also positive, plus 15, no x on that. Questions on the synthetic division portion before we move on to the factoring portion? Okay. Says find the remaining factors. Again, remaining factors. And specifically the word factors. Factor the DP. And that's all we have to do. Again, you have to pay attention to the directions. So now I'm going to take my DP up here. 2x squared plus 13x plus 15. Now there is a major difference between this problem and the previous 2 trinomials that I've factored. What is it? Anybody see it? I know someone sees it. Please tell me. Thank you. Appreciate it. You have a number on in the A's position that is not 1. When that happens, it makes our problem more complicated. Again, remind ourselves, we have A, B, C here. So when I set up my factors, we have our x's per usual. I like to do this as a trick. If you're new to me, you'll get used to this real quick. Once I find these two numbers, after I do that, what do I do with that 2, with that A? It doesn't just hang out up there. Slide and divide. Once I find these two numbers, which I'll do in a moment, I divide by the 2. What I like to do to get ahead of that, because students very often forget that step, they forget to go back and divide by the A, I like to put it in first and foremost. As soon as I notice that the A is not 1, I go ahead and put that step in there. So once I get these numbers, I'll divide by 2. So I'm going to go ahead and put that there. That way, when I get to that step, it's already there, written for me, and I don't have to think about it. Now that I've taken care of that, I'll find the two factors that we need. ACB chart. A is 2. 2 times 15 is 30. And B is 13. 30 here is positive, so we're adding on the right side to get that number 13. 30 has 4 pairs of factors. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And we want the 2 that when added will give us 13. Clearly that's going to be 3 and 10. 3 plus 10 does equal 13, so these are my two factors. We have plus 3 and plus 10. From here, we can take care of that 2 that we're dividing those by. And this is where we do slide and divide. We look at our numbers. If we can divide them nicely, then we'll do it. Otherwise, we'll slide. 3 divided by 2 is a decimal, so I'll slide that 2 in front of the x value, giving me 2x plus 3. My second set, 10 divided by 2 is just 5, so I'll do that. X plus 5 for the second set. And I'm done. All I had to do was factor the DP. Questions over that process, over the problem? One more problem. This one is going to be majorly different in format from the previous two. Given a 0, find the rest of the zeros of the function. So we're given a 0. This 0 is right here, x equals negative 3. When we start the synthetic division process, this part is important. Normally, we change the sign. That's when it's written as a factor. This one's written as a 0. It's already solved for us. We don't need to change the sign. Already solved. Don't change the sign. That's one big difference with the 0 problem. Again, you have to pay attention to the directions. So we'll start with the synthetic division. And I'm going to rewrite this as a division problem, checking the place value first. X cubed, x squared, x, no x, we're good. Our problem is 1x cubed plus 4x squared plus 1x minus 6 divided by, and I'll just put negative 3 in parentheses. Just to emphasize, I don't need to do anything to it. We already have just the number. Let's set up the synthetic division. Put the -3 in the backward cell. Again, we don't change it. And we'll take all our coefficients from above. 1, 4, 1, -6. And then draw the line for your workspace. Let's begin. We'll bring down the 1, the first coefficient. From here we multiply, add. 1 times our divisor, -3, is -3. And then we add down. 4 plus -3 is +1. Repeat. 1 times -3 is -3. Add down. 1 plus -3 is -2. And one more time. -2 times -3 is +6. Be careful with those signs. And then we add down. -6 plus 6 is 0, which is what we want. Now we assign place value. 0 is the remainder. -2 gets no x. 1 gets an x, and the next one gets an x squared. Then we write the dp. Starting with the first term, 1x squared, I'll just write x squared. Next term is positive, so we'll put a plus. 1x, or just x. -2, no x on it, no remainder. Questions on the synthetic division before we finish up the problem? The next set of directions are different. Find the rest of the zeros. Zeros being the important word here. The previous two problems, what we found were factors written in the factored form. We want zeros, which are just the numbers. X equals whatever the number is. This is what we did on the front side with just the equation. We're going to do this exact same process here. When it says zeros, you set it equal to 0 and solve. I'm going to write those directions again. Find the zeros. Set dp equal to 0. Factor and solve. We go a step further on this problem. So on this problem, if you just factor like we did on the previous two, you would lose a point because you didn't go far enough. Let's take our dp. X squared plus x minus 2. And we'll set that equal to 0. Don't forget that part. We'll factor first like we have been. Got our x's. Don't forget the equals 0. Keep bringing it down. And then we'll set up an ACB chart. A here is 1. 1 times -2 is -2. B in the middle is also 1. Since the C value has a negative, we are subtracting to get that 1. 2 only has one pair of factors, 1 and itself, 1 and 2. Now we're able to get 1 by subtraction. Which number has to take the negative for that to happen? The 1. Negative 1 and positive 2 does give us positive 1. These are the factors. X minus 1, x plus 2. We have this equal to 0. That means we're not done. We still have to keep going. We have to solve. From here, we split this up into 2 equations. X minus 1 is equal to 0, and x plus 2 is equal to 0. And then we solve both of those. Left equation, I'm going to add 1 to both sides, giving me x equals 1. Right equation, I'll subtract 2 from both sides, giving me x equals negative 2. And then just to clarify, these are zeros, which look different from factors. So again, make sure that you're giving them what they ask you for. If they want factors, give them factors. If they want zeros, give them zeros. If you give them the wrong type, you will lose credit for that.